I forgot to mention that more about core coupling you can find in the documentation hub. We will run the virtual Hil device. Now we have got a new tab, Hil control panel for our induction machine. As you can see, we got 4 sections. It's for source, for machine, for the inverter, and our user-defined values. For the source, we will define 230 volts and press enter. Under the machine section, you can set up some initial values, and our load settings from the control panel are disabled. We have disabled it under the inside of the induction machine. We choose the model. Now, under the user define, you can define our load, you can enable our model, and type a speed, wanted speed, reference speed. We'll type, for example, 1000. Press enter. You can run the simulation, open the machine section, and enable. As we can see, the machine is speeding up. And we have got a reference value of 1000 RPM. We can make adjustments and run our model from this part, from simulation control, but later we will use the custom user interface to control and to see behavior of our machine. Now we can go to the capture and simply observe a few signals. For example, we can observe VAB. Then we will observe, for example, current in phase A. We just type A. We will observe integrator output. And sign out. Our simulation is running, as we can see. Now we will go to the display setting and turn on the 4 viewports. In the first viewport, we would like to observe voltage between phase A and B. You can see we have got PWM signal. In the second one viewport, we will observe a current. Third one, we will use the integrator output. And I cannot see here, we have to go back to this and sign out. Stop simulation and run again. And it's here. It's signed out. Signals are not steady, so we will use a trigger. We will trigger the current IA. Now we got the trigger point. Lift it a little bit up. It's a little bit steadier. We can go to the capture mode, take the settings from the scope, and click on the force trigger. These signals are what we got. This is signal. This is the voltage between phase A and B. This is the current in phase A. This is integrator output. This is angle for our sine block, and this is the sine output.